rules. Please only write these if you are specifically asked. Any other time, like only if I say, what is the recursive rule? Unless I ask for that, don't write this equation. You're probably never going to see me ask for that. Okay, here's what it means. It literally means, so you're only going to plug in numbers here. A1, first term, you will put something right here. You're going to put whatever the first number is. Wow. In the sequence. The only other place where you will put something is right here. What do you think that stands for? Talked about yesterday. Common difference. You will only replace those parts. Everything else just stays as is because it's just explaining what's happening. What this tells you is like the first term is blank. And then you take your previous term and you add some number. Okay. For geometric, you will only replace this. So that becomes your first number in the sequence. And then you will also replace R, which is your common ratio. Everything else remains. So you're going to have a lot of G's, you're going to have a lot of N's. Leave it. Okay. It's like someone is talking this out to you in a sentence. The first term is, here's what this says. The first term is 2. That's what this part says. You don't have to write this out. I'm just like explaining it out. First term is 2. This equation right here says to get another term, add the common difference of 3. It's like it explains it out to you in a sentence. It literally even has a comma. Weird. I know. Okay, so we're going to write the first 6 terms of the sequence. The first term is 2. To get a next term, that's what the n minus 1 means, take the previous term and add 3. So what's the next term? 5. And then add 3. 8, 11, 14, 17. So the first term, A1, is here. The common difference is 3. The equation tells you that. You can write the sequence from a recursive rule because it explains it out to you. These should be G's, right? G, G, G. Okay. The first term is what? 1, G1. So 1. What are we multiplying by? Right here. 3. This is geometric. It's got a G, so you know you're multiplying. So multiply by 3. Next number is 3. 3 times 3 is 9. 9 times 3 is 27. If you keep going, what's the next one? 81, and then I think it's 243. So we have the first term is 1. The common ratio is 3. That's what this tells us. Is this arithmetic or geometric? That's arithmetic, I think. Is that right? Yeah, because it's subtracting what? Adding. Oh man, thank you guys. Okay, you're right. It's adding 12. Here's your first term. It's negative 30. Your common difference is 12. Okay, we're going to plug in. To write a recursive rule, we're just going to follow what's in that box there. You will say the first term, A1, is negative 30. It's like you're writing a little sentence for me. To get a next term, take the previous term and add what? 12. This is a recursive rule. Notice how it's got a bunch of weird ends. It still has that in there because it's like you're explaining to someone how you would get it. This is like I'm literally only replacing A1 with the first term and the common difference. That's it. I told with this yesterday. If it's dividing, you have to multiply by a fraction. This is like an exponential function. This is geometric. What's it dividing by? 500, 100, 24. What's it dividing by? It's dividing by 5, which means it's multiplying by 1/5. The first term is 500. So your recursive rule, following this equation at the top, G1 is 500. To get any other term, multiply by 1/5 to the previous term. That's what that says. Done. That's a recursive rule. It's weird. I understand. But you leave it like that.